So I've spent the last month or so worth of mornings building this feature flag demo. And it's a proof of concept of a feature flag system very much inspired by LaunchDarkly, but written and running in ColdFusion, or specifically Lucy's CFML for this proof of concept. And the idea here is we have our frame set, which you can see. And on the left, we have a demo application. So these are sample users, and these are two different feature flags that are being targeted at these users. And on the right here, we have an administration module for the feature flags. And you can see we have our operational feature flag. That would be a long-lived flag. And then we have a product flag, so that'd be a feature flag. And both of those are being targeted here. And what we can see is that targeting is not enabled in either of these flags. So every user is getting the fall through variation. And you can think of a feature flag as being a set of variations, and a variation is chosen for a particular user based on targeting. Let's just quickly create a dummy flag so you can see. So let's just say test, and we'll say key test, and this is a demo. And what we can see is that we can choose multiple types here. Boolean is going to be what I use in 99% of my cases, but we can also choose numeric, string, or serializable. Basically anything that can be serialized can be used as a feature flag. And you can see that our log levels are actually serialized structs. And you would just go and you'd set up a set of variations. You can have more than two variations. So we could add a variation here and call it true. We could add another variation and call it false. This doesn't make sense for Boolean, but it's possible. So let's just cancel out of that because we don't need to walk through that. Let's look at our targeting, because targeting is really what makes feature flags magical. So I mentioned here targeting is turned off, so everybody gets the default variations. And let's go ahead and look at our logs. So by default, if targeting is disabled, or if no rules get matched against a particular user, the user gets the fall through. So right now everyone's getting errors state for their log levels, but we can change that. Let's go ahead and switch this to info. And if we hit save, you'll see immediately everyone over here switches to info. But that's a pretty broad stroke. So maybe we don't want to do that. So let's come back in here and we'll set the default level back to error, and let's just save that so we can see that happening. And now let's start to get more specific. So maybe this one particular user who's an admin, we want to set their logging level to trace because they're in the middle of debugging something. Well, first we have to turn on our targeting, because again, if we don't have targeting enabled, everyone gets the fall through. Then we're going to add a rule. And when we add a rule is a series of tests that get ANDed together. And if they pass, then they get passed on to this rollout. So in this case, we're going to use a user key test. So we're going to test just the ID of this user, which is 1. We'll say is 1 of 1. Now, if this test pass, we want this person to get trace. So let's go ahead and save this. And you'll see immediately this user got trace and everyone still has errors. Now, maybe what we want to do is target a user property. So in this example, we have a number of people who have @example.com and a bunch of people who have @acme.com. So maybe what we want is the admin in example to get tracing, but we want everyone else to get info. So let's go ahead and add another rule. This time we're going to test a user key property, and we're going to say email ends with @example.com, and we're going to add this as a value. And these people are all going to get info. And if we save this, you'll see that our individual targeted user still gets trace, but now all of the users who were part of example.com got info. And so you can see we can really start to target the way our features get rolled out after our code has been deployed. And that's the magic of feature flags, the separation of the deployment from the release. Now let's go ahead and just remove these rules so we can get a little bit more interesting. Let's save this. All right, so now everyone's back to error. So now what we can do is, let's say instead of targeting a particular user, we want to do a distributed rollout, a weighted rollout based on percentages. So now we're going to add a rule. And by default, if there are no tests in a particular rule, they will match against everybody. But now, instead of us using a single layout or a single rollout, we're going to switch over to a multi or a weighted rollout. And now you can see we have options for each one of our variants. Right now, let's say that 30% get trace, let's say 30% get debug, 30% get warning, and 10% get warning. Oh, sorry, info and then warning. And now what we'll see is that some people get info, some people get debug, some people are getting trace, and some people are getting warn. And that's all based on the percentages, right? So we could come back in and say, well, actually, what I want is 30% to get trace, and let's say 0, 0, and 70% to get error. Now, if we save that, you'll see that a bunch of people have error and some people have trace. And what it's doing under the hood is it's taking the key, the unique index, the unique value associated with a particular request, and it's creating a CRC32 hash computation, and then it's using that to create bucketing between all of the various variants. So anyway, I'm pretty excited about how this works. There's probably too much code to show you, but I will just show you the code that runs the actual demo itself. So here are all the test users that we have, and here are the two keys that we're looking at in this particular demo. And what you'll see is we're going to loop over the users, and we have this Strangler object. The Strangler pattern is a pattern in computer programming where we kind of siphon off traffic and then move traffic over into a new use case and then eventually kill off the old use case. So as we're looping over each user, we're going to get the variant associated with a particular feature key. And that's essentially these keys that we were seeing here over on the side. So we're passing in the key. And then in addition to passing in the key, we have to pass in the user key and the user properties. You can think of feature flag evaluation like a pure function. I have to pass in the data that I'm using in my rules engine to determine the targeting. So for example, let's come back here. Let's remove this rule. And let's just save this again. And everyone's back to error. So now if we go in here, what we'll see is that if we add a rule and we do a user property test and we test kablamo and nobody has kablamo, and let's say foobar, we add that value and they get trace, you'll see that nobody here switched over to trace. And that's because no user was passing in a kablamo property with a value of foobar. So because of that, we can never match against those particular users. So you have to think about it as a pure function. You have to pass in all the data that you're using in your targeting. If you don't pass in a property that the targeting needs, the targeting will fail and the user will fall through probably to the fall through variation, or they would fall through to the next rule. And you can move the rules up and down in this list for priority. So yeah, we just get the variant. In this case, the operations variant is a struct. In this case, the feature variant is a Boolean. And you can see we're leaning hard into the idea that ColdFusion is highly dynamic. I don't need separate methods for returning Booleans versus numbers versus strings versus structures. It can all just come from get variant, and we don't have to worry about the sort of ceremony that comes with a more type heavy language. And yeah, and that's let's quickly look at Strangler just to see how it works. Okay, so here's the get variant. And we load our feature flags. Feature flags are complex structures. And essentially, we're calling the get variant on a particular feature flag. And if we look at the feature flag, and we look at the get variant, we can see how the rules engine works. So if the feature flag is not enabled, we're going to return the fall through variant. If feature flags are enabled, we're going to loop over the rules. And then for each rule, we're going to test the rule using the given user key and the given user properties. So again, we have to pass those into every rule. Think of it as a pure function. What you put in is what you get out of it. So if the rule passes, it returns a variant, and then we return that variant. And if none of the rules pass, then again, we use the fall through variant. So we use the fall through variant if targeting is not enabled or if none of the rules pass. And the rules, if we just quickly look at a rule, if we test the rule, a rule is nothing but a series of tests, and each test also has a test user method. So essentially, the rule is a set of tests, and they all have the same API. And then if none of the tests, or if one of the tests fails, we short circuit with 0, which is the non-matching variant ref. Otherwise, we defer to the rollout, and we get the rollout variant. And remember, rollout can be a specific rollout, or it can be a weighted distribution rollout. And then the test, let's just quickly look at the test. We have our user key test and our user property test. If we look at the user key test, we only ever look at the user key for a given operator. If we have a user property test, we're going to look at a a user property against an operator. And there's a whole bunch of different operators. We have contains, ends with, greater than, less than, matches regular expression, doesn't match regular expression, doesn't end with, etc., etc., starts with. And these all have the exact same method, test value, and they take a particular value and then they match it against the things that we've configured in our feature flag. What I've tried to do is take all the little aspects of the feature flag and break them down into very simple components, which is how, again, we come back to our Strangler here, and Strangler just calls get variant on each feature flag, and then that feature flag loops over some rules and calls test on the rules, and we end up with a variant that either works or doesn't work and returns the faulty variant. There's a lot of code here. I'm rushing through it because there's way too much to reasonably cover in a video. But I'm hoping that seeing this in action and seeing how easy it is to dynamically target a particular user at runtime, that's really where the magic of feature flags are. So probably more to come on this, but this was a really fun proof of concept to put together. And I just love ColdFusion, and this really forced me to think about code in a different kind of way. This is very highly structured data. I'm not really familiar with working with data of this type. Most of the data that I use fits very cleanly into a relational database. And if we look at the sample file here of the JSON, I mean, this is some pretty complex data. We have our arrays of variants, we have our rules, which are arrays of tests, which have operators in them, and operators have sets of values, and we have our different rollouts. And I've just never thought about parsing, validating, persisting, and then representing this type of data in code. So it was pretty exciting. That's why it took me about a month worth of mornings to actually get this working in a way that felt satisfying. So anyway, again, more to come. And if you haven't tried feature flags, you really got to try them out. Very exciting stuff. Really changes the way you do development.